Today, we're diving into the essential world of conduit work, specifically the nuanced techniques and specialized tools involved in bending and cutting. It's a critical skill in many trades, requiring precision and the right equipment. To start, Alex, can you lay out some of the foundational terms we need to understand when we talk about bending conduit?
Absolutely. It's like learning a new language. We have a 90-degree bend, which, as the name suggests, changes the conduit's direction by that exact angle. Then there's a back-to-back bend, which means two 90-degree bends with a straight section in between, essentially forming a U shape, often used to fit between obstructions. Concentric bends are interesting. These are 90-degree bends in multiple parallel conduit runs, where each bend's radius increases as you move from the inside to the outside.
So it's about maintaining parallel spacing, even through the curve. That makes sense. What about the terms related to measurement and fitting, like developed length or gain?
Good question. Developed length is simply the actual length of the conduit you'll be bending. Gain is a crucial concept because conduit bends in an arc, not a sharp angle. This arc actually saves you material. So gain is the distance saved by the arc of a 90-degree bend compared to what a straight line measurement might suggest. You subtract the gain from your total desired length to get the developed length needed.
That's a subtle but important detail. An offset and rise?
An offset involves two bends in a single piece of conduit, designed to change its elevation, perhaps to go over or under an obstruction, or to enter a box cleanly. A rise refers to the length of the bent section measured from the bottom, center line, or top of the straight section to the very end of the conduit being bent. It's also known as a stub-up, a term also used for conduit penetrating a slab or the ground. A 90-degree bend is also known as a stub, which is often what we see when conduit penetrates a slab.
So a stub-up is essentially a 90-degree rise. Let's move into the tools. What's the primary use for a hand bender?
Hand benders are primarily for bending electrical metallic tubing, or EMT, and smaller diameter conduit, typically from 1/2 inch up to 1 1/4 inch. An interesting point is that a single hand bender can often bend both a certain size of EMT and a smaller size of rigid conduit. For instance, a bender for 3/4 inch EMT can also bend 1/2 inch rigid conduit because their outside diameters are very similar.
That's a practical consideration for electricians. Now, what about cutting conduit? What tool is most commonly used for rigid metallic conduit or intermediate metallic conduit?
For RMC and IMC, a pipe cutter is frequently used. The process involves securing the conduit in a pipe vise, marking the cut, then placing the cutter with its wheel on the mark. You tighten the cutter, rotate it to start the cut, ensuring the blade is pulled into the conduit, and tighten the handle a 1/4 turn for each full rotation around the conduit. It's important not to over-tighten. You might also add a few drops of cutting oil to the groove, avoiding skin contact, and continue cutting.
And there's a specific technique at the end of the cut, isn't there?
Yes. Quote, "When the cut is almost finished, stop cutting and snap the conduit to finish the cut. This reduces the ridge that can be formed on the inside of the conduit." End quote. After that, you clean both the conduit and the cutter with a shop towel rag and then ream the conduit.
Reaming is often overlooked by the uninitiated. Why is it so critical to ream conduit after cutting?
It's absolutely essential to remove burrs and sharp edges. If you don't ream, those sharp internal edges can damage the insulation of the wires when you pull them through, leading to shorts or other electrical hazards. To ream, you place the conduit in a vise, insert the reamer tip, apply light forward pressure, and rotate the reamer using a downward motion, as rotating it incorrectly can damage the reamer itself.
Safety first, always. Shifting to another material, what about bending PVC conduit? Can you use a hand bender for that?
No, PVC requires a hot box or other specialized methods because you need to heat it to make it pliable. It's important to remember that PVC conduit is not threaded for electrical applications.
And
For RMC and IMC beyond the hand bender, is there another specialized tool for bending, particularly for more intricate bends?
That would be the Hickey bender. It's specifically for RMC and IMC and functions quite differently from a hand bender. A Hickey is a segment bending device. You start with a small bend, about 10 degrees, then move the Hickey and make another small bend, repeating until the full bend is achieved. You have to be careful not to flatten or kink the conduit because Hickeys offer less support to the conduit walls. They should be used carefully, unlike hand benders which offer more support. And they are sometimes used for stub-ups in slabs and decks.
So it's more about incremental adjustments rather than one smooth pull like a hand bender. What's used to prevent wrinkling or flattening when bending larger PVC?
For PVC 2 inches or larger, you use a plug set. You insert a plug into each end of the conduit, then use a hand pump to pressurize the conduit to about 3 to 5 psi before you apply heat and bend it. This internal pressure keeps the conduit from wrinkling or flattening.
Oh, that's clever. Now, when we need to join threaded conduit, what tool do we use to make those threads?
That's where a die comes in. Conduit dies cut a taper of 3/4 of an inch per foot. The number of threads per inch varies with the conduit's diameter, usually between 8 and 18. You'd use a thread gauge to confirm the threads per inch.
Moving back to bends, we discussed offsets earlier. What's the main purpose of an offset bend?
The primary purpose of an offset bend is, quote, to allow conduit to pass over or under an obstruction, end quote. This could be a beam, another conduit, or for proper entry into meter cabinets and junction boxes. An offset typically requires 2 equal bends, each less than 90 degrees, spaced a specific distance apart.
And there's a practical consideration when choosing the degree of these offset bends, isn't there?
Indeed, it's a trade-off. Quote, the smaller the degree of the bend, the easier it will be to pull wire through it, end quote. The larger the degree, the harder the wire pull. So you always want to use the shallowest degree of bend that allows the conduit to clear the obstruction and fit in the space.
That's an important insight for long-term functionality. What about a saddle bend?
A saddle bend allows conduit to cross another conduit or obstacle. When you make a saddle bend, the center of the saddle actually shortens. For every inch of saddle depth, the conduit shortens by 1/8 of an inch on each side of the bend. So for a 2-inch pipe, a saddle bend would cause a 3/8 inch shortening on each side.
That shortening calculation is crucial for accurate measurements. Let's look at an example. If we're making a 10-degree offset to cross a 6-inch obstruction, what should the distance between those two bends be?
Using the standard NCCER multiplier for a 10-degree offset, which is 6, you simply multiply the offset height by this factor. So for a 6-inch obstruction, it's 6 multiplied by 6, which gives you 36 inches between the bends.
Simple multiplication once you know the multiplier. And if those two bends in an offset weren't aligned correctly, what would result?
You'd end up with a dogleg, a bend that isn't straight or true, which can cause significant problems during wire pulling or installation.
So precision is key. If a bend is slightly off, is there a way to adjust it?
Yes, you can often use the handle of the bender itself for minor adjustments to get the bend just right.
We've covered pipe cutters, but what about hacksaws for cutting conduit, specifically EMT?
EMT is typically cut with a hacksaw. The key is blade selection. For EMT, you'd want a blade with a higher tooth count, like 32 teeth per inch. For rigid conduit and IMC, a lower tooth count, say 18 or 24 teeth per inch, is more appropriate. When using the hacksaw, you secure the conduit, position the blade angled slightly down, and make even strokes until the cut is clean and straight.
It sounds like understanding these tools and terms is fundamental to successful conduit installation, whether you're dealing with offsets, saddles, or simple 90-degree bends. The precision in measurement and the correct use of each tool are paramount to a safe and functional electrical system.
That's exactly right. From understanding gain to knowing when to ream or use a plug set, each detail contributes to a professional and reliable installation, ensuring the longevity and safety of the electrical infrastructure. Also remember that RMC, IMC, and EMT are available in standard 10-foot lengths.
This conversation has illuminated many of the complexities and crucial considerations when working with Conduit. Thanks for breaking it all down. If you found this discussion helpful, consider sharing this episode with someone who might find it valuable too.